Okay, hello everyone in a new video. So we have reached part 13 of chapter 7, which is the chapter of Newton's second law for grade 11 students. So in this one we are going to solve some exercises on the projectile motion. And let me start exercise 17. Fadi throws a basketball with an initial velocity v0 is equal to 6.5 meter per second. So the initial velocity of the projectile is given by 6.5 meters per second at an angle of 50 degrees with the horizontal. So let me give the angle here. So let me say that this is alpha 0. Then in this case alpha 0 is given by 50 degrees, which is the shooting angle of the projectile. Now when released, the ball is 2.3 meters above the ground. So here 2.3 meters represent the height at which Fadi, so okay, at the instant where Fadi is in the air because he jumped, so 2.3 meters represent the height from the center of mass of the projectile with the horizontal. So in this case y0, okay, yet we didn't choose the reference system, above the ground, neglect air resistance and take g is equal to 10 meters per second square, which means that we are performing this experiment on the surface of the earth. Now, okay, part 1, notice that here we didn't choose a reference system, okay? So, number 1, they are telling what are the components of the ball's initial velocity in the vertical and the horizontal direction. Choose the ground as the origin. This is extremely important. So here they are forcing me to choose the origin to be the ground. So this is the positive x-axis because the origin is contained here, and this is the positive y-axis. Okay. And this is the original. Why? Because they are telling me choose the ground as the origin. So the origin is somewhere here. And what about, so this is the x-axis contained along the ground. What about the y-axis? The easiest case that we can consider is that the y-axis is the line of action passing through the center of mass of the projectile, which is the ball, which is this point, okay? So, and the origin is the intersection between the x-axis and the y-axis, which is this point. Now let's refer back to the question. In number 1, they are telling me what are the components of the ball's initial velocity, the vertical and the horizontal direction. So this is v0. So the components of the velocity, they are asking me about v0x and v0y. Okay, then they are telling me write with complete derivation, so we need to derive everything from scratch, the parametric equations and the velocity equation of the motion of ball. So the moment they mention the parametric equations, then we write the position, the velocity or the speed and the acceleration. First, let me start by the components v0x and v0y. So v0x and v0y, so these are the components or the projections of the vector, which is given by v0 is equal to v0xi and v0yj, and these are determined via projections. So this is the initial velocity v0. So in this case v0x, notice that this vector is pointing in the positive direction of the x-axis, so it's plus the magnitude, which is v0 multiplied by cosine of alpha 0, okay, which is equal to, okay, now, so if we plug down 6.5 multiplied by cosine of 50, plugging this on the calculator, then it's giving by, so 6.5 multiplied by cosine 50, then this is equal to 4.18, and the SI unit of speed is given by meters per second. Now as for v0y, it's pointing in the positive direction, so plus v0. Now this angle here is given by pi by 2 minus alpha, which is 90 minus 50, which is 30 degrees. So cosine of pi by 2 minus alpha 0, which is 6.5 multiplied by cosine 30, which is equal to, sorry, it's cosine 40, because 40 plus 50 is equal to 90, and this is equal to 4.98 meters per second. And now here, if you check, if you take the square root of v0 x squared plus v0 y squared, which is equal to square root of 4.18 to the power 2 plus 4.98 to the power 2, you must get 6.5 meter per second, which is the initial speed, which is the magnitude of the velocity vector. Now let's start deriving the parametric equation, and this is done by considering Newton's second law on the projectile. Apply Newton's second law, which is given by sum of forces is equal to ma. So what are all the external forces acting on the ball at this instant? We only have the weight. So weight is equal to ma. And now in order to determine the acceleration, to deduce the parametric equations, we need to project. So let's start by the projection along the x-axis or the y-axis. Now in this case, we drop down the vector quantity, and each vector quantity will carry the label y. So wy is equal to may, and in this case wy is minus w because it's pointing in the negative direction. So minus mg is equal to may, which means that ay is equal to minus g. So we have that the y component of the acceleration is equal to minus g, in which g is the gravitational field strength. Now as for the projection along the y-axis, we have that wx is equal to max, and the x component of the weight is 0. So this is equal to max. Knowing that the mass is different than 0, then ax is equal to 0. So in this case, ax is equal to 0. Now, since we have specified the values of ax and ay, we can directly discuss the type of motion along the x-axis, the y-axis, which allows us to derive completely the parametric equations of this projectile. So now let me say, okay, motion along the x-axis. Just 1 second. So since ax is equal to 0 verifies the general form, then the type of motion is URM along the y-axis, along the x-axis, sorry. And in this case, we can directly say that x is equal to vxt plus x0. Vx is equal to a constant, and ax is equal to 0. Now, as for the motion along the y-axis, we have that since ay is equal to minus g verifies the general form, a is equal to constant, then the type of motion is uvrm along the y-axis. So So we have that y is equal to half ayt square plus v0yt plus y0. Now vy is equal to ayt plus v0y, and as for ay is equal to a constant. Now after we have specified the type of motions and determined these, let me make some space here. Then simply the parametric equations along the x-axis are given by x is equal to v0 cosine, so alpha 0 t, because we have determined, sorry, let me explain. Now knowing that Vx is equal to a constant, then it can be determined from any instant. We only know the initial instant regarding the velocity, so this is also equal to v0x, but here we have determined v0x and is given by v0 cosine alpha 0. Then x is equal to v0 cosine alpha 0 multiplied by t plus x0, and Vx is equal to a constant which is given by v0 cosine alpha 0, and ax is equal to 0. Now as for the y component, so ay is given by minus g, and as for v0y we have determined and it's given by this. So as for the y component, we have that y is equal to minus half gt squared. The minus sign is coming from the fact that ay is equal to minus g plus v0 sine alpha 0 t plus y0, and vy is equal to minus gt plus v0 sine alpha 0, and ay is equal to minus g. So these are the general equations. Now let me replace some values. So okay, what about x0 and y0? So this is the position of the projectile at the instant t0, and this point is labeled by the coordinates x0, y0 that are given by, so the value of x is 0 and the value of y0 is 2.3 meters in the SI. So this is given by 2.3 and this is given by 0. So the equations then are given by the value of v0 cosine alpha 0 is given by 4.18, no need to calculate them again. T, the value of x0 is 0, then Vx is equal to 4.18 meters per second. So whenever quantities are not expressed in terms of another quantity, it's convenient to write down the unit. Notice that here, okay, before, let me say that y is equal to minus 5t squared. Always in the case of projectile, this factor is given by minus 5t squared. As for v0 sine alpha is given by 4.98 t. As for y0, notice that here y0 is not 0 and it's given by 2.3. Now notice that, okay, before minus 10t plus 4.98, if you check the values, and ay is given by minus 10. Here, as a double check for our answer, notice that Vx is related to x by an operator which is the derivative, and the derivative of the linear term is a constant, and the derivative of a constant is 0. As for this, the derivative of quadratic term is linear, the linear is constant, and the constant is 0. So here, check, what is the derivative of this? Is given by minus 5 times 2 times t plus 4.98 plus 0, which is simply this one here, okay? And what's the derivative of this one? Is simply what? Minus 10t. So this is a double check that our answers are completely correct, okay? So each component is related to the other by an operator which is a derivative. Now notice that also the derivative is an important operator in physics, because it relates a quantity to another quantity in which the link between them is a difference in unit, which is time, which is second. So notice that the unit of position is meter, the unit of speed is meter per second, and the unit of acceleration is meter per second square. So the derivative links one quantity to another quantity, and it changes also the unit. So from here to here we apply the derivative, and the derivative changes the unit by second, and here by another second, which is give us second to the power 2. So the derivative is an operator that links a quantity to another quantity such that these two quantities are related by time. Okay, so now this if we are deriving with respect to time. Now in number 2, they are telling me write the position vector of the velocity, write the position vector of the ball at t is equal to 0.2 seconds. This is straightforward. We know that the velocity vector at any instant is given by vxi plus vyj, in which this is the instantaneous velocity. Now Vx is given by 4.18 multiplied by I independent of time, because the type of motion along the x-axis is uniform. As for the y component, is given by minus tt plus 4.98 the unit vector g. So this is the instantaneous velocity, which is explicitly depends on time, and this is given by 4.18 I plus minus 10t plus 4.98 j. Now if you are interested in determining the position, sorry, they are asking me about the position vector and not the velocity vector, sorry. Okay, so the position vector is given by the vector r, which is equal to xi plus yj. So we must read the question very carefully. So the x component that explicitly depends on time is this, and the y component that explicitly depends on time is this. So this is the position vector that explicitly depends on time. Now we are interested in determining the position vector at a specified instant, which is given by 0.2 seconds. Then r replacing t by 0.2 seconds, which is equal to 4.18 multiplied by 0.2 multiplied by the unit vector I plus minus 5 0.2 to the power 2 plus 4.98 multiplied by 0.2 plus 2.3. Now this is, here we are adding two vectors, so they are I and j. So let me calculate the x component. Then 4.18 times 0.2, it's given by 0.836 multiplied by the unit vector I. As for the y component, which is more complicated, then it's given by 3.096 j. So what does this position vector tells us? It gives us the position of the point with respect to the origin. So at the instant t is equal to 0.2 second, the values are given by 0.836. Let me write them down here. So at the event labeled by the instant t is equal to 0.2 seconds, sorry. The position of the ball will have an abscess at 0.83.6 meters. So somewhere, say for example, if this is 1, so this is the x, and the y is 3.096. So this is 2.3, so it will be somewhere here on the trajectory, okay? So this point here represents for t is equal to 0.2 seconds. Now this is it for number 2. Now in number 3 they are telling me show that the time taken for the ball to reach the basket is 0.69 seconds. So recall that in the case of the problems like the projectile motion, any event is labeled by 3 parameters or 3 labels. They are given by x, y, and t. Whenever we know one, we can determine the 2 others by referring to these equations, okay? Now they are telling me that we need to show that this event is labeled by the time t is equal to 0.69 seconds, okay? So for this event, what do we know? We know the distance x from the origin. And what is the link between x and t is simply this equation, okay? So straightforward, we know the value of x, we can determine the value of t, and for sure it will be given by 0.69. So using the equation x is equal to 4.18 t, and we are interested in determining the value of t, so x divided by 4.18, the value of x is given by I think 2.9 divided by 4.18, so this is equal to 0.69 seconds. Okay, now we are sure that this time is given by, we can remove the question mark. Now here in this case we are done with parts 1, 2 and 3. They are telling me in part 4 calculate the height h of the top of the basket. So we need to calculate this height h, which also correspond for this event, which is given by 0.969, and we have y explicitly as function of t. Then replacing the value of t, which is given by 0.69, we can determine the value of y. Let me copy the dependence of y on time, which is given by y is equal to minus 5t squared plus 4.98t plus 2.3, and t is given by, so for y, so let me say that this distance, which is denoted by h, which corresponds to y for t is equal to 0.69 seconds, which is equal to minus 5, 0.69 to the power 2 plus 4.98 multiplied by 0.69 plus 2.3. Now we expect that this value must be positive because h is positive. And indeed it's given by rounded to the second significant, and it's given by 3.36 meters. So also this event is labeled by the height, which is given by 3.36 meters. Okay, and we are done with part 4. Great. Now in part 5 they are telling me determine the range of the trajectory of the ball. So what is the range? The range is the distance from the horizontal distance separating the, so the range is the horizontal distance separating the shooting point with the point at which the ball reaches the horizontal. Now suppose here if we don't have the basket, so the ball, it will continue its trajectory like this. So this is the intersection point. This is the horizontal distance separating the shooting point from the point of intersection of the ball with this horizontal line. So this is the range. Okay, and the range is determined by the equation y is equal to y0. So y, which is given by minus 5t squared plus 4.98t plus 2.3. Now notice that here when we are interested in determining the range, which is r, which is somewhere here from the distance from this point to this point, we need to find the distance, which is a horizontal distance, which means we need to find the value of x. But in order to find the value of x, first we need to find the value of t. Okay, so we are solving for the equation y is equal to y0, which is equal to 2.3 meters, which means that minus 5t squared plus 4.98t is equal plus 2.3 is equal to 2.3. So minus 5t squared plus 4.98t is equal to 0. Now what's the type of this equation? This is a quadratic equation in t. How do we solve it? Either by factorization or by calculating the discriminant delta. So minus 5t plus 4.98 equal to 0. T for sure is different than 0, which means that t is equal to 4.98 divided by 5. Plugging this on the calculator, then it's given by 0. Almost 1 second. Okay, so if we are rounding, then this is given by 1 second. Now we didn't calculate the range, we calculated at the instant that describes the event of the range. Okay, now whenever we need to calculate the range, we expect that the range must be greater than 2.9 meters because this distance is less than the range. Now we are ready to calculate the range using this equation, which is x. So the range is simply given by r, which is given by x for t is equal to 1 second, which is equal to 4.18 multiplied by 1. Everything is expressed in the SI, so this is in meters. So the range is equal to 4.18 meters. Okay. Another way to determine the range is using the formula, which is given by or r is equal to v0 square multiplied by sine 2 alpha divided by g. So here you should if you want to use this, either you can prove it or you should memorize it. So now let's try it. So the value of v0 is given by 6.5 to the power 2, because v0 to the power 2 multiplied by sine of 2, the angle is given by 50, I think. Yes. So this is equal to 100 degrees divided or suppressed by 10. Then this is equal to it's given by something 4.16 meters. Now the difference between this value and this value, because we are considering rounding to the nearest second significant. Okay, so this is the difference in the answer. What else? And I wanted also to say the following remark, that we can also achieve this range, which is given by 4.18 meters, by another shooting angle. This angle is given by 90 degrees minus 50 degrees, which is equal to 40 degrees. So here this man, given by Fadi, can also achieve this range, but not this point, by another shooting angle, which is given by 40 degrees. Okay. Indeed, they are telling me for which angle other than 50 degrees will the ball cover the same range, and notice that will cover the same range and not will reach the basket. So let me say the other angle is given by 90 degrees minus 50 degrees, which is equal to 40 degrees. So 40 degrees makes the projectile covers the same range. We are done with part 5 now. As for part 6, they are telling me calculate the velocity of the ball, direction and magnitude. So let me split the following question into determining the velocity as a vector and then to deduce the direction and the magnitude. Okay, because whenever we have the vector, we can directly determine the direction and its magnitude. So at the maximum height is given by this point. So it is described by which constraint or which condition. At this point, the maximum height, the velocity is tangent to the trajectory, which is completely parallel to the x-axis, which means that the y component is 0. Okay, so if the y component is 0, no need to calculate time. Notice that we are interested in determining the velocity vector. So let me do this part here. So we are interested in determining the velocity vector, which is given by v is equal to vxi plus vyj, okay, which is equal to 4.18i plus minus 10t plus 4.98j. Now notice that here at this maximum height, the velocity is completely parallel to the x-axis, which means that this is 0. Okay, here no need to calculate time because this is the quantity that we want, okay, which is the velocity vector. Now let's determine the direction. The direction is determined by tangent alpha is equal to vy divided by vx, but in this case also no need to determine the direction because the direction is completely obvious here. It is horizontal to the right. Okay, no need to determine. If you want to use the tangent alpha, so let me say the tangent alpha is equal to vy divided by vx, which is equal to 0 divided by 4.18, which is equal to 0. Then using the calculator, shift tangent and alpha is given by 0 degrees. What does it mean? So what does it mean that alpha is equal to 0 degrees? It means that v is completely parallel to the x-axis, or you say parallel to the x-axis. Okay. As for the magnitude, v is equal to square root of vx squared plus vy squared. So this is 0, which is equal to square root of vx squared. Since the magnitude will take the positive solution, which is given by 4.18 meter per second. Okay. So this is it for exercise number 17. Now let me move to the other exercise, which is exercise number 18. Also, the projectile has a lot of applications in related to military stuff. Now, an aircraft flies at a height altitude with respect to the ground level. When its radar detects an enemy tank, the aircraft changes its direction and flies obliquely downward with a constant velocity v0, in which v0 is equal to 100 kilometers per hour. Notice that kilometers per hour is not the SI unit of speed. In order to convert from kilometers per hour to meters per second, we simply divide by 3.6. Then dividing this quantity by 3.6, then it's given by 30 meters per second. Okay, and making an angle alpha, which is equal to 30 degrees with a horizontal when the aircraft is at a height h is equal to 2000 meters. So this height h is equal to 2000 meters. With respect to the ground, it releases a bomb trying to bombard the tank. This is interesting. And take g is equal to 10 meters per second square, which means for sure this being performed on somewhere at the earth. Okay, here we must be very careful about the orientation of the axes. So this is the x-axis, this is the y-axis. So this is the bomb, this is the projectile. At an instant, it's being placed here, okay? So now if you consider the weight, notice that the weight in this case is in the same direction of y. So expect that ay is equal to plus g and not minus g. And they are telling me to determine the parametric equations of the motion of the bomb. So let's start by apply Newton's second law. Although questions somehow at some point they are repetitive, but always we need to repeat them carefully and make sure that if there is a change in a minus or a factor. Okay, so we have that sum of forces is equal to ma, and the different forces that are acting on the bomb are the weight, which is equal to ma. Okay, so projection along the y-axis. Now we drop down the vector quantities, and each vector quantity will carry the label y. Now notice wy in this case, if this is the weight, it's pointing in the positive direction of the y-axis, so it's plus w, which is equal to may. So mg is equal to may, and in this case ay is equal to plus g. Now as for the projection along the x-axis, we have the wx is equal to max. No projection for w along the x-axis, so this is 0, which means that ax is equal to 0. So now after we have specified the values of ay and ay and ax, we can determine the type of motion along each axis. Let me start by the x-axis. So since ax is equal to 0 verifies the general form, then the type of motion is URM along the x-axis, which means that the type of motion that the equations of motion are given by, let me write them here, okay, or here, x is equal to vxt plus x0, vx is equal to constant, and ax is equal to 0. Now as for the y-axis, since ay is equal to g verifies the general form, a is equal to constant, then the type of motion is uvrm along the y-axis, which means that the equations of motions are given by y is equal to half ayt square plus v0yt plus y0, vy is equal to ayt plus v0y, and ay is equal to a constant, which is g. Now let me rewrite these equations considering the correct projections. So let me start with the x component. Okay, here we have, so okay, let me write them here. So notice that in this case Vx is constant, which means that Vx can be determined at any instant. The only instant in which we know the velocity vector is given by V0. So Vx in this case is equal to V0x because it is constant. What's V0x? It's the projection of V0 on the x-axis. So it's a plus V0 multiplied by this by the cosine of this angle, which is cosine alpha. So this is given by Vx here is given by V0 cosine alpha, ax is equal to 0. So this is v0 cosine alpha t plus x0, which is 0. As for the y component, what do we have? We have y. So the value of y0 is given by 0 because this is the origin. The projectile at the instant t0, t is equal to 0, y0 is equal to 0 because it coincides with the origin. Now as for v0y is equal to plus v0 and the cosine of this angle, which is pi by 2 minus alpha. So cosine of pi by 2 minus alpha, which is equal to v0 sine alpha. So and ay is equal to plus g. So vy is equal to gt plus v0 sine alpha. So half gt square plus v0 sine alpha t. Okay, now if you need to replace some values, we are done with these. Now in this case x, now v0 is given by 30 multiplied by cosine 30, which is equal to 25.98 t. Now vx given by 25.98 and ax is 0. As for the y component, we have that y is equal to 5t square. So 5t square is an indication that this is a projectile. The minus because due to the orientation of the axis, plus v0 30 multiplied by sine 30, which is equal to 15t. So this is given by vy is equal to 10t plus 15, and ay is equal to 10 meter per second square. Also, whenever a quantity is expressed as a constant, it's convenient to write down the units. So as you can notice that these quantities are linked by an operator, which is derivative, especially that they are all of them are related by time, as well as for these, if you apply the derivative, you see that they are linked. The quadratic term give us linear term, the linear term give us constant, same for here, linear term give us constant. Linear term give us a constant, the constant give us a 0. Now in number 2, they are telling me determine the trajectory equation, and the trajectory is equation that completely relate the position and x and y independent of time. We can go for here and replace the linear term in y, but instead let's do starting from the general form and determine the general form of the trajectory, then replace the values of v0 and alpha. So let me say that x is equal to v0 cosine alpha t, which means that the linear term of time is given by x is equal to v0 cosine alpha, and from the y we have that half gt square plus v0 sine alpha t. Now replace t and y, we get that y is equal to half g 1 divided by v0 cosine alpha x to the power 2 plus v0 sine alpha x over v0 cosine alpha. So notice that here v0 disappears, tangent alpha sine alpha over cosine alpha is tangent alpha. This power 2 eventually is for the numerator, and for the denominator we have that y is equal to half g1 divided by v0 square cosine square alpha multiplied by x square plus tangent alpha x. Okay, this is the general equation of the trajectory of a projectile. Now notice that in physics we cannot add or subtract quantities unless they have the same unit. This is meter. What about the unit of this factor? So notice that this is given by meter per second square times 1 divided by meter per second to the power 2. The cosine is dimensionless, and this is meter square. So meter square cancel with meter square here, second square with second square, and we are left with meter, which is meter. As the same for this because tangent alpha has no unit. Now we are ready to replace some values. We have that y is equal to half 10 multiplied by 1 divided by 30 to the power 2 cosine 30 to the power 2 x square plus, so this is also okay, tangent 30 x. Now y is given by, so let me put it in terms of the fraction 1 over 135 x square plus tangent 30, which is given by 0.58x. So what's the type of the trajectory in this case? Parabola. Okay, linear in one term, quadratic in the other. We are done with numbers 1 and 2. Now, number 3, they are telling me determine the velocity as the bomb reaches the tank. So, okay, we need to determine the velocity. Let me write the equation of the trajectory here. We have y 1 over 135 So we need to determine the velocity as the bomb reaches the tank, which corresponds for this event. Now the velocity vector is given by Vxi plus Vyj, which is equal to 25.98 multiplied by the unit vector I plus 10t plus 15 multiplied by the unit vector j. Okay. Now in order to determine the velocity vector, we need to determine the value of t, which is here. And what links this to other is okay, we need to know either x or y if we are interested in determining t. So linked to this event, which is given here, for this event we know that y is equal to plus 2000 meters. Y plus, because y, this point is given by the coordinates given by d, which is positive, and h, because we are measuring with the positive direction with respect to the y-axis. So what's the link between y and t is this equation. So we have that y is equal to 5 t squared plus 15t. So 2000 is equal to 5t squared plus 15t, which means that 5t squared plus 15t minus 2000 is equal to 0. What's the type of this equation? Quadratic in t. It's extremely difficult to solve by factorization. Then we can go for the discriminant delta and plugging it on the calculator. Then it's given by two values of time. The first time is given by t1 is equal to 18.56 seconds, and t2 is given by minus 21.56 seconds. Time is absolute and positive, so this is rejected and this is accepted. After we have determined this instant t1, which is correspond for this event, then v is given by 25.98 I plus 10 multiplied by 18.56 plus 15 j. So 25.98 I plus 200.6 j. Then this is the velocity vector at the instant corresponding for that event. Done with number 3. Now in part 4 they are telling me calculate the horizontal distance d. This is which part? Part 3, sorry. Now as for part 4, this horizontal d is dictated by the instant t1 is equal to 18.56 seconds, which correspond for replacing here an x. Okay, so let me do it here. Then part 4, d, which is equal to x for t1 is equal to 18.56 seconds, which is equal to 25.98 multiplied by 18.56 seconds. Plugging this on the calculator. which is given by 482.19 meters. So this is the separation distance between the launching of the bomb and the position of the tank. Okay, so that's it for me in this video, guys. In the next part we'll complete solving exercises on the projectile.